students, today we are going to discuss about the combinational circuits in digital electronics. So what are the combinational circuits? Combinational circuits are the circuit which is made up of logic gates. And what are the logic gates? We earlier discussed logic gates are the building block of any electronic circuit, and the output of the logic gates based on the inputs. So there are three type of main logic gates, that is AND or NOT, and two universal gates known as NAND or NOR, and two exclusive gates XOR and XNOR. So what are the combinational circuits? It is the output of a combinational circuits is totally depend upon the input. That means there is no memory element in the circuit, and the output is totally depend upon the input. That means there is no feedback path in the circuit. So if there is no feedback path in the circuit, that means there is no memory element in the circuit, and because of that, no memory element, that because of that the previous outputs have no link with the next output. So combinational circuit is a memory less circuit. So on the other hand, we have one other circuit known as sequential circuits. Sequential circuits are also made up of different type of logic gates, but the only difference between a combinational circuits and the sequential circuits are sequential circuits are having a memory element. That means in sequential circuits the feedback path is there, and the previous inputs or previous outputs have a very major role, plays a very major roles in the coming outputs. So we can say that the basic difference between a combinational and a sequential circuit is, in a combinational circuit there is no memory element, that means it is a memoryless circuit. In sequential circuit there is a memory element, so it is we can say that there is no feedback element, there is a feedback element, no feedback path, there is a feedback path. So these are some basic differences between a combinational circuits and sequential circuits. Today we are only discuss about the combinational circuits. So we can say that it is a circuit in which we combine the different gates in the circuit. For example, encoder, decoder, multiplexer, demultiplexer, and some of them are like adder, subtractor. So the output of a combinational circuit at any instant of time depends only on the levels present at the input terminals. The combinational circuit do not use any memory. The previous state of input does not have any effect on the present state. We earlier said that there is no link with the output. That means the previous outputs don't have any kind of link with the coming output. So in the combinational circuit only this will happen because there is no memory element in the circuit. So the combinational circuit can have n number of inputs and m number of outputs. So we can see that this is the basic diagram of a combinational circuit. That means A, B, C to the power n are the inputs and these are the outputs. So there is no memory element, there is no feedback path, so the output is only depend upon the inputs. So in the next we can say that the another circuit under the combinational circuits are half adder. What is adder? As the name suggests, adder means adding. The addition of 2 bits is known as half adder. The addition of 3 bits is known as full adder. So an adder is a digital circuit that is used to perform the addition of numeric values. It is one of the most basic circuit and is found in the arithmetic logic units of computing devices. There are two type of adders, half adder and a full adder. So a half adder is a combinational logic circuit with 2 inputs and 2 outputs. 2 input are, we can say that A and B are the 2 inputs, and outputs are when we add the 2 inputs, means A plus B, that will become sum, and if sum is one output and carry is the other output. So the half adder is designed to add 2 single bit binary numbers, that means A and B. It is the basic building block for addition of 2 single bit numbers. This circuit has 2 outputs, carry and sum. If we have 2 single binary digits, that means A and B, then the half adder adds them with the circuit carrying 2 outputs, the sum and the carry. The carry represents an overflow in the addition of the 2 numbers. So we can see that this is the half adder circuit diagram. So A and B is the, first of all we can see this thing. Okay, like A and B, when both the bits are 0, then A plus 0 plus 0 becomes 0 and carry 0 because there is no overflow. When 1 plus 0 becomes 1 and no overflow in the addition, that means carry becomes 0. Then 0 plus 1, then that will become 1 and no overflow with the carry, so carry will become 0, and 1 plus 1 is equal to 0, and with the, because in binary digits when both the inputs are high, that means 1 plus 1, then the addition would be 0 with the carry 1 because there is a overflow in the addition. So in this, for this diagram we can see that for some process, for some only this bit is high and this bit is high, that means A is positive, B is negative, plus A bar B plus A B bar. This is the equation for sum. For C carry, this bit is high, only this term is positive, so we can take only these two. So A plus B, AB. So for carry we are having AND gate, and for sum, because this thing one time A is positive, A is negative, next time B is negative, B is positive. So for sum we are having XOR gate, and for carry we are having AND gate. By using these two gates we are preparing the half adder circuit diagram. So you can see that for carry, A, B are adding going through the AND gate, it will become carry, and A and B is going through the XOR gate, it will become sum. So when we add only 2 bits, then it will become half adder. Now we are going to add 3 bits, A, B, C. So full adder is developed to overcome the drawbacks of the half adder circuit. It can only add 2 1-bit numbers A and B and carry C. The full adder is 3 input and 2 output combinational circuit. The full adder overcomes the disadvantages of the half adder in that it can add 2 single bit numbers in addition to the carry digit at its input. So you can see that full adder, first of all you can see this, okay, A is 0, B is 0, C is 0, so A, B, C, then A, B, C in, A, B, C. So in first bit you can see that this 0 plus 0 will become 0, and this 0 plus this 0 becomes 0. So sum will be 0, no overflow in the carry, that means carry will be 0. Now next input 0 plus 0, that will become 0. So then this output 0 plus 1 becomes 1, and no overflow, that means carry is 0. Similarly you can see that 0 plus 1 becomes 1 and 1 plus 0 becomes 1. So sum will be 1 and carry will be 0. In the last you can see that 1 plus 1 will become 0 but carry would be 1. Then 0 plus 0 will become 0. So this will be 0 but the previous carry is 1. So the carry will be 1. Similarly 1 plus 1 will become 0 but the carry will be 1. Then 0 plus 1 will become 1 but there is already 1 carry. So 1 is the carry. Now in this sum, this position, this position, this position and this position, these 4 positions would be high. So in this A bar, B bar, C plus A bar, B, C bar, and this A, B bar, C bar, and then A, B, C. In carry, these 4 positions will be high. So A bar, B, C, A bar, B, C. Now A bar, B bar, A, B bar, C. Next is A, B, C bar, and the fourth one is A, B, C. So with the help of these two, now first of all, for sum, this A, B is going through the XOR gate, and this one and this one will become go to the XOR gate. Now this will become sum. Now this XOR gate and this will go to the AND gate, and this A and this B will go to the AND gate. Then the output of these AND gate will going through the OR gate. So this will become carry output. So with the help of this we can make this, like in the previous we see that with the help of this we make this. Similarly in full adder, with the help of this we can make this. So next combinational circuit we are going to study about the subtractors. So as the name suggested, like adder, addition is going on. In this subtractor, subtraction is going on. So a subtractor is used to subtract one number from another, because we are dealing with the binary digits. The 1's complement and 2's complement of the number are used to achieve this. 3 bits are involved in performing the basic subtraction, and which is like we can see that in this, in as adder there is a sum and a carry. Similarly in subtractor there is a difference and borrow. So subtractor is a combinational circuit with 2 inputs and 2 outputs. It produces the difference between the 2 binary bits at the input and also produces an output to indicate if a 1 has been borrowed. In the subtraction A minus B, A is called a minute bit and B is called the subtrahend bit. So when a subtraction is done between just 2 bits is known as half subtraction, similarly like half adder, and when it is continued with the 3 bits then it is known as full subtraction. Like in a half subtractor you can see that 0 minus 0 will become 0, then borrow is also 0, but 0 minus 1, that means A is 0 and B is 1. So this minute is less and the subtractant is high, so this will become difference is 1 and the borrow is also 1. Then 1 minus 0, we can easily subtract 1 minus 0, that is 1, and the bit will become 1 and borrow will become 0. Then 1 minus 1, the both will become 0. Similarly in difference, these two will be the high bit. So A bar B plus A B bar, so these will be high bit. In borrow only this will be high bit, so A bar B. So A bar B, so we can see that A bar, that means in borrow we need A bar. So if A is 0, A is 1, then it will go through the NOT gate. If we can take A is 0, that means okay. If we take A is 1, that will it will automatically go through a NOT gate and going through the AND gate. So in this difference we will take XOR gate and it will become XOR and difference. So similarly with the help of half adder we can conclude with the half subtractor, because with the help of truth table we can make the circuit diagram. So in a full subtractor, similar as we earlier studied, that the full adder is used to overcome the disadvantages of half adder. Similarly full subtractor is used to overcome the differences or used to overcome the challenges of half subtractor. The disadvantages of half subtractor is overcome by full subtractor. The full subtractor is a combinational circuit with 3 inputs and the having an output of difference and a borrow. So similar, the full subtractor is equal to the half subtractor, but the only difference is in half subtractor only 2 bits, in full subtractor it is having 3 bits. So the combinational circuit of the full subtractor performs the subtraction operation on 3 bits, the minute, the subtrahend and the borrow bits in. So the circuit generates 2 output known as the borrow bit and the difference bit. So in this full subtractor you can see that 0 0 0, so the difference 0 minus 0 0, 0 minus 0 0, so 0 minus 0, that will become 0, but 0 minus 1, the difference will be 1 and the borrow should also 1. So 0 minus 1 1 and the difference borrow should also 1, then 1 minus 0, it will become 1 and the borrow, earlier the borrow should be 1. Similarly 0 minus 1, difference is 1 but the borrow should be 1. Borrow should be 1, then 1 minus 1, that will become 0 but the borrow should be 1. So 0 1, you can just check it with the diagram of this. So in full subtractor, this bit, when the bit is high means 1 is the answer. This bit is this bit and this bit, these all bits should be high. In borrow, these 3 bit and plus this bit is high. This bit is high means only we will take these inputs. This bit is high means we will take only these inputs. This bit these inputs and this bit is these inputs. So we will only continue with these bits inputs, that's it. So with the help of these inputs we will perform full subtractor circuit. So by using this we will conclude the difference output and the borrow output. So we can study only two combinational circuits, the half adder, full adder, half subtractor and full subtractor. So the adder and subtraction, the combinational circuit of adder and subtractor is basically equals to each other, because adder is performing addition and subtractor is performing subtraction. Half adder is used to addition of 2 bits, full adder is used to overcome the process of half adder. So basically full adder is used to addition of 3 bits. Similarly, in half subtractor it is used to subtract the 2 bits, and in full subtractor it is used to overcome the half subtractor, or used to difference the 3 bits. So in a full or half adder we are having two outputs, that is carry and sum. In full and half subtractor we are having two outputs, that is borrow and difference. So today we are going to conclude with the combinational circuit of adder and subtractor. And we can see that in a combinational, we already talked about that, in a combinational circuit there is no memory element, in sequential circuit there is a memory element. That means in combinational circuit there is no feedback part, but in a sequential circuit there is a feedback part. This is the only difference we are going to be taking in our mind, that is that what is the combinational circuit and what is the sequential circuit. So in the next lecture we are going to study about the multiplexer, demultiplexer and encoder and decoder. So thank you.